What's good, everybody? In my video today, we're talking about absolute value functions and transformations. If you find this video helpful, smash the like button for your boy. So we start off with our original parent graph. Y is equal to the absolute value of x. You'll sometimes see f of x instead of y, but it's the same thing. And what we need to know is that when we graph, our x and y values are going to be the same. So we'd have 1, 1, 2, 2, 3, 3, and so forth. So in our first example, they give us this absolute value function. They tell us to graph it. And we need to know that HK is going to represent our vertex. So the vertex in this problem would be -2, 3. After we set what's inside the absolute value equal to 0, we're going to get x is equal to -2. So when we go out here, this is what our graph should look like. I mean, the vertex should be at -2, 3. Now, we need to find more points so that we could graph the absolute value function. And there's two ways to do it. We can either use the slope in a problem like this, which is 1, or we can use a table. So what we're going to do, we're going to pick 2 points to the left and to the right of our axis of symmetry. Right? So when we plug 0 in, 0 plus 2 is 2, 2 plus 3 gives us 5. So I know when x is 0 and when x is -4, we're going to have a y value of 5. So let's just make sure that we put that. So here goes 1 point, and when it's -4, it's also going to be 5, which should be right here. Now when we go back and plug in -1, -1 plus 2 gives us 1. The absolute 1 plus 3 is going to give us 4, and we have 2 more points for us. So now we could go ahead at -1, 4, and -3, 4. So now we have a few points, and we could draw a line through them and create that V-shaped graph. And if you think about it, with slope, we went up 1 over 1, up 1 over 1. So just remember, guys, 2 different ways for us to graph absolute value functions. In our next problem now, what they did was they put a negative sign out in front. But before we get there, let's think about the regular transformation, right? When it's x minus 3, this is letting us know that we're going to shift this graph to the right 3. So 1, 2, 3. This would be our new vertex at 3, 0. So this would be our graph if there was not a negative out in front. Now that negative we know makes the graph open down, but just think about it also as a reflection over the x-axis, meaning we made our shift to the right 3, but instead of this graph opening up now, it's going to be reflected over the x-axis, and now it's going to be opening down. So just please, guys, remember that when it's opening down, it's also can possibly be a reflection over the x-axis. In problem number 2, they now gave us a factor in front of the absolute value. So they gave us an a. And there's no transformation. We're not shifting the graph up, down, left, right. What they're letting us know is that this graph is going to be compressed. It's going to be wider. And the way that we can do this or find the other points if we don't use a graph is use the slope, right? Rise over run. So I could go up 1 over 2, right? And I could do so on the other side as well. Up 1 over 2. So just please remember, guys, this is another way that we could graph an absolute value function like this. Use your slope, or you could think of it as, hey, whatever your x is, your y is half of it. So this would be 2 comma 1, -2 comma 1, and let's say we pick 4. So when x is 4, we know y is 2 because it's half of the x value. And we're just going to plug in the other point on the opposite side of the axis of symmetry, which is -4, 2. Last problem of the day, but before we go, if you guys found this video helpful, just smash the like button for me. Really helps other students to see this video as well. So now they try to fool us, right? They put a coefficient in front of the x, and now it kind of makes it a little bit complicated, but it really doesn't. Please just follow the same steps. So what we're going to do is set it equal to 0. 3x minus 6 is equal to 0. 3x is equal to 6. We know x is equal to 2, right? And then when we look at the transformation, we now know we're going to go two places to the right and up one. So my vertex would be at 2, comma 1. Now, we can't use the slope because this is not in the same format. That 3 kind of throws us off. So what we're going to do, we're just going to create a table and find at least one more point. Right? So we have x, we have y. We know when x is 2, our y is going to be 1. So now what we're going to do, we're just going to pick 1 and 3. We know they're going to share the same exact y coordinate. So 3 times 1 gives me 3. 3 minus 6 is going to give me -3. The absolute value of -3 is 3 plus 1 gives me 4. We could go on to 0 and 4 if you want to get more points. But we're going to stop right here for the video's sake. So now we have 2, 1. And then now we have 1, comma 4, which should be about right here. And then 3, comma 4, which should be right here. So understand, guys, that in a problem like this, we probably can't use the slope, all right, unless we do like a rise over run of like 3. And then we can now go ahead and draw our graph. So whether it's using a table or using the slope, guys, these are two different ways you could graph absolute value functions. Hope this video is helpful for you guys. Thank you so much for joining me with Algebra 1 with Mr. Peters.